So here we have the SOP adaptation. We can see the adaptive SOP that's active currently. And there's a macro step. So the first macro step is active. And within the macro step M1, the filling of the recycle collection tank, we can see that it's in step 7. So that's the filling of the slurry mixing tank. Wait for the level to get to 30 again, like you did previously, and then it starts flowing to the jet cooker. No, wait, you wait for the level to get to 70% eventually. I'll just move that on so we get to the adaptive SOP part. So inactivate that, fires the next step. And this is a step where the outflow ramps up within 10 minutes to 150 cubic meters an hour. So that's happening here currently. And that's ramped up nicely. And it's gone into the second macro step. We can see the dextrose equivalent because there's no dextrose yet. An example of the second SOP adaptation, there's no dextrose yet, so it has a D of less than 10. In the second macro step, the first SOP adaptation happens, so that's the ideal solids loading you want in the outlet of the slurry mixing tank. So it seems to be a good value now. It should be between 27 to 29, and that determines the residence time you want in final liquefaction. So if we go to the liquefaction pages from the slurry mixing tank, let's see what's happening there. So that condition has fired, and we can just click on the arrow from here to move there to the slurry mixing tank. No, to the jet cooker. Again, it waits for the temperature to get to 90. I'll just disable that condition so we move on to see final the adaptive SOP. So if I come in here, it's at this point where it's waiting for the temperature to get to 90. I'll disable that so we can fire on. So it's come to the jet. Alright, so it's now in liquefaction. So if we open the liquefaction vessels, we should see a level rising there, which is what's happening here. So we want the residence time in final liquefaction to depend on the solids loading. So currently that's the solids loading that we have. It's the correct value. Depending on variability in the feed material, you can have different solids loading irrespective of what you load in. So currently it doesn't seem like there's a lot of variability in the feedstock, so it's a standard feedstock that's being used now. Normally you want the level to rise here before you start feeding to final liquefaction. I'll just disable that and allow the simulation to proceed. Again, I'll disable that level just to see what happens with the adaptive SOP. So it's come to that step now where it's starting the feed flows into final liquefaction, and we can see the level in the final liquefaction tank rising again. You wait for the level to get to 184. I disable that just to see. So in the SOP adaptation, only one of these parts gets fired. So if currently that's the path that would be fired, so these ones wouldn't fire because the solids loading seems to be at the right value. So if I disable that step here, just so we move on, so we see that step there, it's fired that step, it's waiting for the time to reach 60 minutes residence time within final liquefaction before it moves on to start feeding onto the fermenter. I'll just wait for that time to go through rather than disabling it. Just to show how the adaptive SOP works in this instance. So let's see what the time is. It's waiting for it to reach about 60 minutes. So currently it's just about half an hour, so that's good. Now coming up to 50 minutes. So in 10 minutes time it should fire. So if we had been on the second path, it should have fired now, that transition condition. Alright, so that's passed. You can see that it's fired. It's once the time reached, it's passed these conditions. It set the valves and the flows into the main fermenter. And if we look at the main graph set pages again, we can see what's happening with what step we are now. Alright, so it's finished with the fermentation. The steps for fermentation happen quite quickly. We see that we had a dextrose equivalent of just 10. So that's the path that would have been fired in this condition. And fermentation is currently happening. You want a residence time of that within the fermenter. And you also want the level to reach an appreciable level. But we can see that path, because the times are very short after the second macro step, 5 seconds. It fires very quickly, which is why it wasn't possible to catch that step firing. But it's very similar to the solid loading step. Ideally, you want the dextrose equivalent to be that value. So again, a little optimization within the model to make sure that we have that value under ideal conditions. So that's the model for both the standard SOP and the adaptive SOP. Thanks very much. Bye.